Greetings to you, all my dear viewers, and welcome to the Water Drops project that is part of GeoNode's challenge series. Why GeoNode's challenge series? Because I'm trying to separate the GeoNode's daily, that I want to make it more concise and fast-paced, to GeoNode's challenge that will be the type of videos where I take my time to explain more things and go more in depth. This is also the second part of this project. The first part dealt with generating the animation. As you can see here, we now have this animation going, and we solve this problem: how we can make particles or mesh stick to another mesh, and also have a precise control over that motion. And we have it because of this curve lines. In the first part also, I explain why that is a good idea to use curves to control the motion of these meshes. And I also explained a bunch of other stuff about how you can get to this step. So if you missed that first part, check the link in the top right corner, somewhere here, and that will take you to the first part. Before getting into the stuff that we will cover in this second part, and by the way, this is what we are going to cover today. We'll use those guidelines to add the droplets that you saw in the demo. We will also turn these ugly icospheres into something that resembles a lot more water drop. And we will also sculpt the droplets, make them stick to the surface, and we will start to work on the pedestal that you saw in the demo, giving it the base shape. So that's what we will cover today. But before we get to that point, two things. One of them, let me activate the screencast keys, and the second one, this method of controlling the tracks using the lines, a bunch of lines, has some limitations. We can control where these things start and end by controlling where this the size of the plane that we use for the beginning, and also the length of it. We'll control how they attach to the surface. We can also play with positioning to get different effects. But we kind of get problem with meshes like this because using a raycast node, as we can see here, we kind of have to slant the lines instead of making them go straight like this. That will make portion like this missed. We kind of have to make it go like this, and that means we can start to lose portions in this area and stuff like that. For the water drops, it's okay, but if you want a more precise control, I found out a better way to do it, and I'm quickly going to show you that first. So let's do just that. I'm gonna do a curve circle, and let us close this for the moment. We are going to just look at this original mesh, and let's plug this circle here. Of course, there is a procedural way to make sure that this circle is always bigger than your mesh. This is still important. But for this example, we'll just leave it like this. Let's rotate this circle on the y-axis. So let's do like 90 degrees, and I will have a circle that goes around the mesh like this. And now if we have this circle and we take this raycast node, we are going to use the original geometry from the mesh, and then use a set position on this circle. Okay, and we are going to plug this position of the circle onto the mesh. As you can see, we get this result. the circle gets stuck to the mesh, but there are a bunch of problems. One of them, we can see this going like this. So if we mute this one, we can wonder what is going on. We still have to fix a problem. Decide the direction of the normal, because now it's a static normal, and that's exactly why we don't want to use a line. We kind of want to make this automatic. And the idea is to have this circle and make the raycast take into account the circle and shoot rays based on that. So this point will shoot like this one will shoot like this one will shoot like this, and so on and so forth. That will eliminate the need to manually adjust the ray direction. So how exactly can we do this? Well, we know that there is such a thing as normal that will point like this away from the points, and we can use that information. So if we take the input normal and we plug it here, giving the fact that this data is going to be taken from the circle, meaning not the target, we kind of get closer to get what we want. But if we switch to wireframe, we see everything disappearing. And the reason is that we are now casting rays away from the mesh, because this is how these points are distributed from the circle. So what we need to do is to invert this normal, and one easy way to do it is to scale it in the negative direction, something like this. And as soon as we do this, if we select our mesh and we look at the result, we kind of get nothing. And if we switch to wireframe and we play a little bit with these values, we can see what's going on. We get again that nasty point right in the middle. It's kind of messing with our setup. So one easy way to fix that, it's using, instead of mesh circle. So let's plug a mesh circle here. Let's make the radius bigger than our mesh. Make sure we have this one here, and let's increase the resolution of this one a little bit. And as soon as we do that, we can see our line appearing. And of course we can play with this, and as you can see, it's gonna stack a lot better to the mesh. Not perfect, you will still have problems like this, but the result will be much better, and it will encompass your entire mesh. So you can do a bunch of other effects using this entire setup. So here you go, a better way to do the stuff that I showed you in the other video. So now it's time to get to the other points in our list. I'm gonna do it a little bit out of order. I want to start with turning the water drop into something else, something that resembles more a water drop. So if we go in our setup, it's exactly as I left it in the previous video. I just colored this animation frame and gave a name to this frame so we know what they do. So we have our water drops here, and right now they are something like this, and they don't look like water drop. Water drop is more something like this. So this is what we'll try to achieve, and we will succeed. We will flatten the bottom and we will elongate the shape. And if you take a look closer to the demo video, as you can see here, I play a slow down version of it. You get another thing on the drops. You see they have like an organic motion. They seem to follow the mesh and to adapt to the surface. That kind of motion, it's a little bit more complicated to achieve, and we will do it in the next part. Now we're just going to focus on basic stuff. So we have our mesh here. First of things first, we need to increase the resolution of these drops. Let's stick here a mesh shade smooth to get a nicer result. So first let's get the elongated shape, and let's make it more visible. Let's do something like this for now. So now we can focus only on this part. So I'm gonna do a frame for this, push it aside, and push this one here, and push this one a little bit like this. And let's add a connection point, and now we will start to work on this part. And what I want to do is to alter the position of these pixels, these vertices, sorry, based on their position. So let's take the position, plug it here, nothing happens. But if we start to play with the values, let's do vector math, switch it to multiply, and if we multiply by 1, we get the original result. But as soon as we start to play with these values, watch out what's going to happen. Now we made it a little bit less fat, and now we can make it a little bit longer by playing with this value here. And let's leave it at this. And now let's take care of this part. If we do it like this, we get like a balloon shape, Zeppelin. So it's not exactly what we want. We would like the bottom part to be more flat than the top part. So this part. How can we do that? Well, let's make a little bit more room here. I'm gonna push this one here, save the file, and we will play with this property that we already experienced here. If we multiply something by 1, it's gonna remain the same value. If we multiply it by 0, we are basically going to cancel it. So if I take this value and replace it with 0, I kind of make everything completely flat. So let's duplicate this node, plug it here. Let's switch it to full ones. And now let's focus on the Z position. Let's separate this one, this vector. By the way, you can find this node in this category. So we use the separate, we will use a combine and plug it here. And in between these 3 values, we will start to do a bunch of stuff. So what exactly do we want to do? First of all, we want to leave it alone on the X and Y values. And we want to check when the points are on the lower part and do something about that. And if we look at this mesh, we see that it's centered half-half. Half of the mesh is above 0 and half of it is below 0. So this is really good for what we want to do. So if we take this Z value and we do a compare on it, and say if it's greater than 0, meaning it's above the line, we kind of get 1, and if it's not, we get 0. So if we play like this, everything that is below 0 will get squashed, and everything that is above 0 will stay in place. So that helps us get what we wanted, in getting this more water drop-like shape. And like I said, in the next video, we will do more deformation to the mesh, and we will make it seem to follow the mesh to be more organic in the movement. So now we can simply reconnect our original setup, switch this to material preview, and we can see our mesh. As you can see, they don't get nicely aligned to the mesh. We will fix that also in the next part. Right now, I'm gonna do only one thing to this. I'm gonna introduce a random variation on the scale of these instances, and that's really easy to do. We're just going to use a random value, and because we want to keep this shape, we can plug this directly here, and let's say between 0.75 and 1. And now if we look at these drops, they will not have the same size anymore. They will have different sizes. So we get this nice variation. At the end of the video, I will show you how you can make some of these parameters smarter, how you can expose it here, and all that good stuff. But right now, I think it's time to move to the next point and use these guidelines to create the water drops and solve a bunch of problems that come with this endeavor. Why we say we'll have a bunch of problems? Let me close this monkey mesh so we can see things better. We basically want to instance water drops behind water droplets behind the water drops and completely ignore the front part, as you saw in the demo. And that's gonna create a little bit of a problem. So let's see, we want to have a water drop, and that's gonna be not hard. Yeah, we can basically use this icosphere from here. Let's do Alt P and Control J, a new frame. This will be our droplets. Excellent. So how can we instance here? We can use the points of these lines to instance the droplets, but we want to do more than that. As you saw in the demo, we have some wet marks behind the water drops that are wider. So we also want to transfer this information to the material, and that will be done by using a proximity node. But for that, we will need a mesh. So we basically want to take this information, this curve, and turn it into a mesh. So let's find that one. Where exactly is it? It's this node. Let me give it a special color so we can find it easy. We need this information from here. So let me frame everything, and let's take this one out here. Let's do a reroute node for now, and see how we can turn this into a mesh. Well, it's not very complicated. We can do a curve to mesh, and plug this one here. And as soon as we do this, let me plug this one here and plug this one here, and we can kind of delete this one. We turn this into a mesh on top of these lines, but we don't see anything because we need a profile. So let's add a curve line and plug it here, and immediately we see something happening. It's not exactly what we want, so things looks very weird because we are giving this a depth in a direction that we don't want. So let's check out what is the right direction. It will be this one. So we can now control just how thick these lines get. And if we want to get them on the both sides, let's do like a 0.1, and we start at minus 0.1, and now we get something like this. And of course we can make it procedural and all that good stuff, but for now let's just make it like something like this, 0.5. Excellent. So now we have this this line here, and it's awesome because if we play the animation we get this. Great. So things seem to be working just fine, but we will have a problem. But let's see what's all about. We have this mesh. We can now do instance point, distribute points on faces, and these are the point faces, and we can add points here. So let's say like 1,000 points, something like that. Awesome. So if we look at our mesh, we have these points distributed here, and that's great. Something like this. And now we can use these points to instance our mesh. So let's do now instance on points. We have these points and we have this mesh here. So let's plug this one here. Obviously the radius it's too big, so let's make it like something like this. For now it will be okay. Okay, let's take this material from the water drops. Material preview, and we have these water drops that are red. So let's do the same here. Alt P, plug this one into this frame, and now we can see the water drops. And things seems to be very, very okay. But check out what happens when we start to play with this. You see our water drops kind of move, and that's not the only part that it's bothering me. They are also popping in and out of existence, you see, and that's not what we want. So how can we fix this part? Well, if we move this from here to here, now we have a point instanced on the entire mesh, and we don't have any popping, but we also lose the information that we need, meaning the water droplets are not aware of the water drop movement. So how can we combine this information? There's a reason I left this noodle here, because this is the information after the trimming, the information that contains the animation of the water drops, and we are going to use it. How? Let's go after this distribute points and introduce a delete geometry, and we will delete the points. And now we see everything gone, but we will create a mask that will look at this information, meaning the trimmed curve, and based on proximity it will decide if these points are distributed before the water drops and therefore have to be visible, or are in front of the water drop, so therefore they have to be invisible, meaning deleted. So how can we do this? Well, let's duplicate this curve to mesh. We need it here, plug it here, and now we can use a geometry proximity, and plug this mesh here. Look at the points, not the faces. Let me delete this point that we don't need anymore. Sorry about the coughing. I'm a little bit under the weather. I'm trying to cough as little as possible, because I take pity on your ears. But it will happen, so sorry for that. So now we have this proximity node, and we are interested in this information, the distance, because we can use this information. Basically, now we are comparing the distance between each point on this spline that we already have here. So we have all these points, and we are looking at the position of them. So we take every single point from this, and we compare it to the points on this mesh, this one here. And doing that, we get a certain threshold that we can use here. So if the distance is greater than a certain value, we will delete the point. And as soon as we start to increase this, you'll see what happens. If we get a small value in the realm of this distribution, because we want to get this distance, how far they are from the line. Remember, we are checking the distance between these points and the points that form this line. So it's the distance between this and this, between this and this, between this and this, and so on and so forth. So we kind of have to cover this distance. Of course, we can make it procedural by exposing these values and connecting to this value and all that good stuff. But I'm going to leave it like this. That's basically the idea. So if the distance is greater than this value, we will delete the points, and it will be greater for the points that are on this part of the mesh, because right now our line ends up here, the one that is getting the drops. So all those drops will be compared to the last point on this line here, and that's why they get deleted, because the distance is greater than this threshold here. So now we kind of fix that problem, because if we look at these points, how they spawn, you see, we don't get that weird popping and moving around, which is awesome. So we fixed this problem. Yay! So what's coming next? Well, let's do this sculpting and make them stick to the surface. And what we mean by sticking to the surface, they seem to stick to the surface just fine. But as soon as we will start to sculpt them, they will not do so anymore. So let me show you what I'm talking about. What we will do with these water droplets is similar to what we did to the water drops, but instead of getting an elongated shape, this is being smaller, and due to physics and gravitation and stuff like that, they will keep their spherical shape, but the bottom will be a little bit like this. And that's gonna be the thing that we want to do. And in order to do that, we have to find this icosphere from here and do a bunch of transform on it. So let's put this transform node. Remember, we are just sculpting one droplet right now. So let's get a little bit closer to see what's going on. We can even switch to water wireframe to see better. And what we want is to do this sculpting, but also make sure that we keep the origin here. So then the stuff gets instanced on the mesh we created. They will be instanced like this and not something like this. That will make them go through the mesh. So for that, we have to expose this value. So let's take an input value and do this 0.01 here. I'm gonna plug this one here. And now let's do a scaling. Let's take a vector, combine X, Y, Z, plug it here, and let's just put it to 1 and see which is the axis that we want to alter. Now we can see we are not altering the right one. Let's check the other one. goes like this, and let's check this one, and this is going to be the one that it's kind of squashing them. So let's play with that. Let's do something about this height. Let's make it like maybe something like this. Great. And now everything seems to be okay. But let's make sure. Let's do something with the translation. I want to use also combine XYZ. Plug this one into the translation and do 0 for these ones and 0 for this one. And let's push everything up by half of this value. So let's do divide by 2 and plug this one into the Z value. Let's hide the other sockets. We don't need that. So right now we get this result. And as you can see, all the droplets are the same size and they kind of stick to the mesh. So let's do some things about that. Let's first introduce a little bit of variation to the size of these droplets. So let's add a random value. Okay, I don't want to be a vector. Float is just fine. Plug it here because I don't want to deform the water droplets. So let's do something like maybe something like this. And as you can see, some of the droplets are smaller, some of them are bigger, and they start to not fit to the mesh anymore because of this size variation. Because remember what we did here, make sure that the origin stays at the bottom, but that doesn't mean that the water droplets will stick to the mesh, given the fact that we kind of change their size. So let's fix that. Let's go here after instance on points, and let's do a geometry, set position. Remember, we still have instances. So basically here we will alter the object, meaning the droplet as is, not the points, even though we use a set position. And that works to our advantage because we made sure that we have the origin here at the bottom. So when we will alter this position by taking this is our monkey, taking this information about the mesh monkey and plug it into geometry proximity. So let's take the monkey data, plug it here, look at the faces of this mesh, and use that position to stick the droplets to the surface. If we were to turn these instances to real geometry, we will basically flatten everything to the surface. But because we are doing it on the instances, we just stick their position to the faces of the monkey, and the sticking point is going to be the origin point that is in our case at the bottom, because we made sure that we push everything up by half of the radius here. So this is how things work. You can play with these values to get something that looks more like water droplets, but you don't have to spend too much time because this is going to be really small and transparent, and therefore not so visible. Okay, so now let's get to the next point. Let's start creating the pedestal for this and doing a basic shape sculpting on it. And after that, I'm gonna show you a bunch of things that I did to make this setup smarter, how I expose values and stuff like that. Great. For this, we kind of don't need any of this data, so let's hide it. This is our droplets. Let's do a layout frame. That's gonna be our pedestal. Awesome. And for that we are going to use a cube, and let's plug this cube here. It's very helpful to work with the origin in mind, especially when you do sculpting, because you have a very easy to use reference point. After you do your stuff, your sculpting, you can then move stuff around to achieve different results. Right now we don't have enough geometry for sculpting here, so let's add a little bit on the X and Y. I want to add a little bit also on the Z, something like this. And now we have a bunch of controls for this, so we can make it longer, let's say like 4 meters, and the Y, let's make it like 2, and on the Z we can leave it like this. So let's just take a quick look at the monkey. I think I want this to be bigger here, maybe something like this. Yeah, it's more like what I did in the original video. So how can we sculpt this? In the demo you saw that this kind of have the shape like this. We will deal with that in the next video. Right now we're just going to introduce a little bit of surface imperfection that will go very well with that procedural material that you saw in the demo. So every time we want to move pixel around, vertices, we will use set position. That gives us access to all the vertices. So we can play with that. Let's do an offset on these pixels. Oh, I don't know why I keep saying pixels. Let's use a noise texture, and we want to offset this. So let's do, because we also want to control the strength of this, let's do a scale vector, plug it into the offset, and then we can use this value here. And now we can control the scale from here. So let's do maybe something like this. And now we can play with the values from this noise. But before we do this, sorry about coughing, check out what happens when we activate and deactivate the displacement. You see how things are moving, and they actually move pretty bad. So check this out. And we don't want that. This noise texture in particular is pushing things in the 0 to 1 range, and that's why we get this movement. And in order to counterbalance that, we kind of have to subtract 0.5 always. So let's do utilities, math. We can use a simple math because we kind of already just use float value. We just convert to something average here. So if we activate this, as you can see, we get the displacement, but we cancel the movement around. Excellent. So now we can play with the values of this texture. This is way too much. The low level details like this, we will do it in the material. Right now we just want to add a little bit of displacement to this. So let's make it round like 0.5. And we can play a little bit with these values, see what happens. And with the roughness, yeah, I think something like this is gonna look just fine. Maybe something like this. So now we have a little bit of detail on this mesh that goes very well with that cracked stone look-like texture that we did in the video. And now we have this node to control the scale of this effect and just how much deformation we get. And this one we shouldn't touch, so let's leave it like this. and then we can control different parameters here, and of course the resolution here. So here you go, a little bit of surface deformation for the pedestal. And I believe we covered all the points I wanted to cover for this series. Let me just reactivate everything and quickly see one thing I want to do. I want to duplicate this node, plug it here, and cut this connection from here, plug this one here. So right now we can plug a transform node here, and that will let us just adjust the entire setup independent on the pedestal. So we can do something like that for now, just to see our mesh. Awesome. So now we have a setup that looks nice, and when we will in the next part, when we will make this mesh go like this, they will go together even better. But now we will look at this setup and see how can we make things smarter. I will show you how I exposed some parameters and what I had in mind when I did that. So if you want to see that, you can stay for that. If not, thank you very much for watching. And if you find the valuable the content on this channel to have value for you, you can subscribe, comment to the videos, like the videos. That will help the channel be shown to more people. So if it will grow, I will have a reason to keep doing this. So thank you for staying to watch this part, making the setup smarter. This is the project file that you can get from Gumroad, and we can see we have this control for size of the water drops. We can make them smaller or we can make them bigger, and by hovering over the value and pressing backspace, we get to the default value of 1. And for that, if we go to the water drops, we have these instances, and we did this scaling using a random value. And what I did to control the scale, I exposed this value. By the way, you can get the group input from here. You can multiply that any number of times, so you don't have to have everything going to one place. You have 1 gazillion noodles, and you can create a new input by dragging a noodle here, pressing N to open this panel, going to the group section, and then you can change different parameters to that one, like adding a tooltip, getting a default value, a range, changing the type if you want, and all that good stuff. So this is how you can expose a parameter. And what I did here, I did a vector math on scale, and I plugged the scale here. So basically we can make things smaller or bigger just by controlling this value. Interesting thing is how I connected the pedestal, that we can control its size from here on all sizes. How can I connect it to the mesh? And you'll see what I mean by that. Let's go to that section. The pedestal. Of course, we have the resolution of this cube, and we have these 3 values plugged here to control the size on a Z, Y, X, and of course to take this into consideration when we do a bunch of other stuff. So that helps us to expose these values, as you can see here. What else will be of interest? If we look at this mesh, we have the water droplets on which we worked, and those have control for scale, seed, droplets. They have a scale, they have an amount that you can control to make less or more, and you can change the distribution by playing with this value, you get different distribution, and you also get droplets scale seed, so you can change the scale distribution, and an overall scale control that can make everything smaller or bigger or stuff like that. So if we go to the droplets here and we look at the values exposed, this distribution amount is controlled from here. We have these distribute points on faces. It has a density. I have a fixed amount here, and then a multiplier to get this 0 to 1 range, to have something that it's easy to understand, not some I don't know what is here. 16,000. What is 16,000? This amount, it's a lot easier. You have 0, you have 0, you have 0.5, it's gonna be like plenty, and if you have 1, you have a lot. It's a lot easier to understand things like that. And if we look at the droplet scale, we have it here. Again, we did the same thing as with the water drops, passed this random value through a vector map scale and control this 0 to 1 range. Again, easier to understand. And then we have the distribution seed, that it's basically controlling the seed of the distributed on point spaces. And then we have a bunch of other stuff here, but we will look at those on the next video, when we will deal with the final parts of this. Meaning we want to transfer this information to the shader, because if we look at the shader here, good, the shader compiled. So if we look at this, we see that where we have droplets, the shader is affected. So this is something we will look at in the next part, how we can transfer this information to the shader. We will also look at these water droplets, and if we look at how they move, they kind of have this organic movement on them, as you can see here. We also have this problem with the water drops. We kind of have to align the rotation. We will do that, and we will add this deformation of the pedestal that you see here. We will also make the rig for the camera. Make a camera follow one of these water drops, meaning we will do another geometry setup, and that's gonna be awesome. So again, thank you very much for watching this video. It's a lot of fun for me going through this project, and I'm trying to explain things as better as I can. But please leave your comments, tell me what you think it should be improved, and I'll try to incorporate your suggestions. So until the next video, if you like this content on this channel,